Alright, so section 6.5 introduces the central limit theorem. So what I've already done is I've taken the chart that we made in 6.3, so here you can see I've copied the chart. I left out the between. The between doesn't really come into play for the central limit theorem. If you want to include it, you can, but it's not really necessary. So back to 6.5. So basically for this, we're just going to end up extending the chart a little bit. So the questions will add what's the probability for an individual distance, and then it'll ask for a mean of a certain amount. So instead of asking for the general population and taking a random individual, it's going to say the population and you're selecting an amount. So if we read the question that's asked, we are going to find, I'm going to go ahead and delete those, we're going to see that the overhead reach distances of adult males are normally distributed with a mean of 205, so we're going to fill in the mean. A standard deviation of 8.3, so we're going to go ahead and fill in that one. Find the probability that an individual distance is greater than 218, so 218 is our number. And we want it to the right, so we're going to use the right, and we're going to use that probability. So we're using the right because if we look at our, there we go. If we look, oh, there we go. If we look at our bell curve and we have our mean here, so we have 205 here, and our x is going to be above that because it's 218, so 218 is greater than 205, so our x is going to be someplace over here, so we'll do that, 218. And we want it to be greater than that, so we want our numbers to continue getting larger, so we're looking for the area that's right here. We're looking for the probability that's there. If it said for a distance less than 218, then we would be looking for the area to the left because those numbers would be less than. So that's the first part of the question. The next part of the question, I'm going to have to erase this picture here so that I have some space. The next part of the question asks, there we go, find the probability that a mean for 15 randomly selected distances is greater than 203.5. So we're going to have to change our x here because it's different now. So we have a distance is greater than 203.5. So now instead of 218.4, we're looking for 203.5. There we go. So we're going to have an n, and our n is what the, I don't want this to be capitalized, it's fine. So our n is just the number that it gives us. So if we read it again, the mean for 15 randomly selected, so that means we're selecting 15 people. I give you the formula here, so we need our n for this part right here. Remember, theta is just standard deviation. So if we have the standard deviation of x, then that is going to be the standard deviation that you have originally. So this is the original. And then your standard deviation, when you have the x bar, that's the new one. So that's the central limit. And that's going to be, so I abbreviated that CL, central limit. And that is basically the new standard deviation for 15. So rather than the entire population, then this one is going to be the standard deviation new. And this is just for your n subgroup. So the next thing that we need to do is, I always put the given standard deviation here as well. You don't have to. You can though, but the given standard deviation is also going to be here in this cell. So I'm going to go ahead and skip it. It doesn't really matter. So the new standard deviation, so that would be the theta. The new standard deviation is what this is, but I don't want to put that in there because I have to find the symbols, so I'm just going to label it as new standard deviation. So that one's going to be equal to the standard deviation that's given, which is right here, divided by the square root, because that's what's part of the formula, of n, and n is 15, so we're going to click that one, and then just hit enter. So that's our new standard deviation. And the next thing that we're going to do is the same thing that we did when we were looking at it on for just a normal population. So when we did it for part A, then now we're going to do it for part B, but we're going to use this new standard deviation instead of the one that we used over here. So z, we're going to do equals, I'm going to round it off because your program likes to round it to a specific decimal point, and for some reason the way the program that you use for your questions rounds and the way that Excel rounds, you end up with like a different answer just because of the rounding error. So I'm gonna go ahead and round it, and when you round it you end up with the right answer, so it's totally fine to do it this way. And it's going to be, let me see here. You're going to use the z, and I give that to you in the first box up top, so it's x minus mean. So I'm going to do x minus the mean, and that is divided by the standard deviation, which is the new one. And I'm going to actually put in way more parentheses than I need. Oop. I'm going to come up here. Go. And this is just to make sure that it knows what it's doing first. So that's the first part of it, and then you're going to do comma, and we're going to round this off to 2 decimal places. So we probably didn't need that red set of parentheses there, but I put them in there just in case, so that way Excel realizes what it's doing first and then what's second. So it's doing the equation first and then rounding to 2 decimal places second. So I'm going to go ahead and hit enter, and it did it for me. So I'm going to actually go home. If you want to see it with those 2 decimal places after, this one comes out to just be 0.7. But you can click your ABC, and in that general one on your laptop, so there's that number section that I was talking about in a previous video, there is these same 2 buttons here, the increased decimal and the decreased decimal, that you can use. So if I increase the decimal, it'll show me that second decimal point, which apparently was 0. So then we're going to find the area of the probability, and I'll do it the same way I did it over there. And you're going to find it the same way. So norm.s.dist, if you go to the left, and I'm not going to write left and right, but I'm going to put them in the same column that they were for the other side, so that's still lined up the same way. Equals norm.s.dist, and then it's going to be your z, comma 1 or true, and then your right is going to be 1 minus norm.s.dist, and it's going to be comma 1. Oh, see, that was my fault. I clicked the wrong thing. Go ahead and fix that. The z, comma 1. And then I might have clicked the wrong thing here too. Nope, we're good. So that is the area of probability for the right or the left. So in this case, it's asking for greater than. So again, we're going to use the right because we want it to be above the x